Okay. Yes.
Like, is there anything on Gradescope or?
There is, well, I don't think I've made a submission for lab 2 yet. But yeah, there should always be a lab. But for these coding ones, it would be shorter than the ones from before. All right. So as I mentioned, we're going to keep doing these short topics on some good coding practices. And today we're going to cover clean coding. So just like we did last time, I'm going to ask you guys, what do you think entails clean coding? What are some things?
Readable code.
So how are you going to achieve readable code? So readable code. So we want detailed comments. Yeah. Anything else for readable code? So let's say consistent. Spacing / style. What else?
Avoid functions inside of functions.
So let's say functions should be short, right? What else do we like? This is it. We're good to go. Don't need to do anything else.
I would like to say something about like labeling variables, like they have to make
Okay.
sense.
So give variables detailed names or meaningful names. What else should we give meaningful names? Give functions. What do we not want to do as well in terms of variables? Or more specifically, the lack of a variable when a variable should exist.
Try not to hard code.
No magic numbers. Right? You should not have like a 10 somewhere in your code. If it is meaningful, give it a name. Like in our code from before, we would put like LED pin, right? We wouldn't just say 17. Anything else? What are some other rules about these naming conventions that we might want?
Camel case or underscore.
So going back to consistent style, right? Do I want my function name to be like 10 words long? Same with variable names, right? Use short names, but still descriptive, right? So really, clean coding boils down all to readable code, right? So I think this is a good list. I'm going to post that as our marked slides. And I'm going to show you guys this other lecture that I have, clean coding. Okay. So this is just a silly comment about clean coding. Have you ever showed your code to someone else? Right? And had them try and understand it without you explaining at all? This is what is going on in their head, right? So one thing to keep in mind is even bad code can function, right? But if the code isn't clean, then sharing that code with colleagues in an organization, it's going to lead to many, many wasted hours of just trying to collaborate on bad code. So why do people write bad code? Right? It's time pressure. I'll fix it later. But really, in the long run, like this quote says, it's going to cost you more time in the end. So this is especially true for like collaborative settings. Like a lot of the time for your small projects, like the ones for this class, or maybe all the way through 311, you're doing very small things. It's only going to be you, maybe one other person that's reading the code. So you might not be thinking about this right now, but it's good to practice it for the future. Because the main thing that you're concerned about right now, right, is writing code that can function, right? But I just want to show you this so that you're aware that not only should it function, it should be readable just through the code itself. And you'll see that I have a slide here that says, actually, comments are kind of failures. If your code needs comments, you just need to write it in a more clean fashion. So how do you know if your code is clean? You just keep practicing it. And again, it's just going to be elegant, efficient, and most importantly, readable, which goes along with simple and maintainable and testable. And again, we care because other people are going to look at our code. So we talked about meaningful names. Here are some rules for meaningful names. We need to use intention revealing names. So variables like int d, we don't like that. If it's going to be a looping variable and it's just going to be used and tossed away, no problem. We all understand I, j, k as looping variables. But if it's something meaningful, like elapsed time and days, give it that name, right? Or days since creation, give it that name. Don't call it some one letter variable. And again, try to avoid disinformation. So if something is something like an account list, give it the name account list. But if it's a dictionary, don't give it the name account list, right? But here is a question for you. You're given this small snippet of code. The question is, what does this do? Is it easy to read very quickly? We can tell what this does, right? What does it do? And what goes in the list?
The index at 0 is 4, and it'll add it to the.
Right. So what are some things that we can do to make this faster to read and understand? Let's start with just one line by line, right? This is the function definition, right? We can tell that it's returning a list of integers. And its name is getThem. Is this descriptive? So we should give it some more meaningful name, right? Like, what is significant about the list index at 0? Right? What is significant about index 0? What is significant about the number 4? Right? So based on those things, we should call it get those things, right? And along the same lines, what does index 0 mean? Give it that name. Is it some attribute that we're keeping track of? And then 4 is like the value of that attribute. Maybe it's like an emotion. And 4 is the encoding for angry. And maybe 3 is sad. Things like that. We need to have some kind of naming convention for these things. We should not have just 0 and 4. Okay? And just these few small changes, even just renaming this function, the code becomes immediately more understandable, because by having the function name, you kind of already know what to expect when you're reading through it. You don't have to figure it out and solve it from scratch. So here is the fixed version. So it's called get flagged cells. So the status value is what's stored in index 0. So they changed it to status value, and the value of 4 means that that cell is flagged. And we've also given a good name for the returning list that we're creating, right? Flagged cells, not just list 1. Right? So this is a lot better in terms of readability and clean coding than this, even though they do the same exact thing. Right? So Rule number 3 is meaningful distinctions. So names must be different. And if they are, they should mean something different too. So we don't like A1, A2, right? And sometimes we like to add more kind of information than is needed. Like we could just call a variable product. We don't need to say product info or product data unless they are actually different things. Okay? But in this case, info and data, they're basically synonyms. So just call it product. And we also want to make distinguishable names. And rule number 4 is use pronounceable names. So we can't just give these random names. This is a shortening of generation timestamp or modification timestamp, but we don't understand that from this name, right? So just give it the full name, modification timestamp or generation timestamp. And also use searchable names. So again, single letter names and numeric constants are not easy to locate, but it's very easy to locate this variable name where we're basically turning that to the number 7. So max classes per student. This is very searchable, whereas 7 is not, right? So this is, again, removing those magic numbers. And like I mentioned before, single letter names are okay for local variables inside very short methods. Example, looping variables, right? So going with those meaningful names, your class names, classes are basically nouns, right? So the classes should have nouns as names. And then methods are things that you do to those class objects. So they should have verb names, like post payment, delete page. And if you're removing some magic numbers, the convention is we use all uppercase names with underscores, right? Like max number, like this max classes per student. And in general, shorter names are generally better than longer ones, as long as they're clear. You only make them longer if it is necessary to make it clear. And you can always rename something if you think of a better name. You can start with one name and then just replace all with a different name if you figure that out. And we all know what refactoring is, right? Do we know what refactoring is? So Mason says no. Does anyone know what refactoring is? Have you heard of refactoring, Kate? Okay. So refactoring is kind of like rewriting code. So say you have some, not a function like this, but like a super long function that you wrote, and really it should be split up into multiple different functions. So refactoring the code would be taking snippets of this functions, copy pasting, making a function out of that, and now you're just calling that function instead. So it's just rewriting code to make it cleaner or improve performance, things like that. So that's what refactoring is. So here is another example. We have this code that works again, right? But it is very messy, right? It's very hard to understand. But following all of the principles that were shown above, it can be shortened into this. And now it's very simple. What is this function doing? It's rendering page with setups and teardowns. And it has this page data object. And a Boolean is sweet. It's going to throw an exception. And is test page. Right? Page data dot has attribute test. So if it is test page, then we're going to get the wiki page from page data. We're going to make a new page content. And then here we're calling a function, include setup pages. So test page, new page content is sweet. All of these things that we just made. And we're going to append this page content to the new page content. And like our function says, we're going to include teardown pages. And then we're going to set the content. And then we return the page data HTML. And here it is shortened by calling this. So render page with setups and teardowns. And it's just going to call, include setup and teardown pages. Page data is sweet. All right. So now going on to functions. Functions need to be small. We like 4 to 5 lines. Right? This is a very small function, right? If you need to figure out what is going on beyond rendering the page with setups and teardowns, you can then read into include setup and teardown pages. And then you can then read into those functions. And it's all split up into these little tiny pieces that are much easier to understand individually than trying to understand this whole piece of code all together, right? So there are exceptions where it could be longer than 4 to 5 lines, but you should hardly ever exceed 20 lines for a function. And rule number 2 is that function should do only one thing. And it should do that one thing very well. And we're following this top-down narrative. So you have your highest level function, right? Calls a little lower level function, and maybe those functions call lower level functions until you get to the very bottom, right? That's this top-down narrative. And again, descriptive names. We want less function arguments if possible. And we want them to have no side effects, as in they only do one thing. The thing that they say they're going to do. It should not do the thing they're saying they're going to do plus this other thing. That's what this side effect means. All right. So here we have a function, check password, and its side effect is a caller who believes what the name of the function says, runs the risk of erasing the existing session data when he or she decides to check the validity of the user because of this initialize. So it's not only checking password, it's also initializing, right? So this function is trying to do 2 things, but it's only saying it's doing one. And rule number 7 is this command and query separation. So a function should either change the state of the object, which is a command, right? or it should return some information about an object, which is the query. It should not do both. Right, so this is going to set some value. It's not going to return some information about the object. And rule number 8 is we like to prefer exceptions to returning error codes. And here is some more clean coding. So we don't really like deeply nested structures. 1 to 2 levels is much more preferred. Sometimes this is unavoidable, like if you have 3D arrays, right? But if you can avoid it, do not go beyond 2 levels. And we all know what I mean by this level, right? The number of indents. And here we go. So comments. So comments, like I mentioned, are failures in terms of what entails clean coding. Because basically, if you're writing a comment, you're saying that you need this text snippet to understand my code, right? But in reality, like we went over, your code should kind of speak for itself. It should have these meaningful names, be descriptive, and easy to follow. And like it says, sometimes we need them, but most of the time you shouldn't need them. And the other thing is, the code is going to change over time. And if you follow clean coding practices, by changing the code, you change the description as well. But if you're relying on comments, you change the code, you need to change the comment. Okay? And sometimes we have like really meaningless comments in code. So one of the more common motivations for writing comments is, again, the code itself does not speak for itself. So rather than thinking that I better comment about that, what I just wrote, think, no, there's a better way that I can write it where I don't need a comment. Right here, so it's saying it's going to check to see if the employee is eligible for full benefits. Okay, so it's got employee flags, hourly flag, employee age. Whereas you can just turn this into a function called is eligible for full benefits. And now I have that same code, but now I don't need a comment. It's self-explanatory. If employee is eligible for full benefits, this is true. If they are not, this is false. So we see this distinction, right? And like I mentioned, some comments are very necessary and useful, like authorship, legal comments, informative comments can be things that go in like the README. And other things like warnings of consequences. Like if you're writing a script, maybe. And then to-do comments are very helpful, right? Because this part has not been done yet. So this is an example of a legal comment. Those are perfectly fine. This is a warning of consequences. Here's informative comments, like look, this is the formats that I'm expecting in terms of times. And then to do comments. And going back to what we talked about earlier too, we like to have consistent style or formatting. So you want to make your code look professional by keeping indentations and line breaks. And we don't want to have lines being super, super long, right? That's what the line breaks are going to be for. So rule number 1 is to separate concepts vertically. Rule 2 is declare variables close to their usage. Rule 3 is to keep lines short. And rule 4 is do not use horizontal alignments. As in, make sure that you use indentation. So we don't like this. We like this. Okay. And then here are some more quotes from someone prominent about clean coding. So that is clean code. Is this all clear to you? So we're gonna take the 20% longer time to write clean code. It takes a lot of practice to get used to it. So it's best to kind of try and get used to it as early as possible, rather than later. Right? We don't want to get used to it after we've been through this thing, right? You want to go to your first code review on this side, not this side. Right? Okay, so that's all for today.